the introduction was that we're going to talk about ZK and Bitcoin. I'll try to, what I want to talk about is how Bob approaches this. I'll also do some introductory information about BitVM. But maybe, to kick it off spicy, ZK rollups on Bitcoin do not yet work. I think that's, the first thing we should get out the way. BitVM, this new mechanism that we're all super excited about, it uses a component, right, that is related to ZK. Specifically, where you do some pre-processing before we commit to these programs on chain. That's where the ZK part comes in. It's a pre-processing step. But what we're working with is optimistic rollups. So, just to get that out of the way. Now, what we're doing with Bob is we're trying to put Bitcoin at the center of DeFi because, we can talk about technology all day. We can build ZK tools, but there has to be a reason for people to actually care and use them. And Bitcoin is the biggest thing that exists on the market, right? Started the whole industry, is bigger than everything else combined. But it does not really have DeFi at all. So that's what's been driving us for me personally, it's been 10 years, for the company 5, to actually improve that. So I always found quite controversial that if you want to use Bitcoin for anything else than payments, you have to go to a centralized exchange. And if you look at the opportunity here, Ethereum's market cap to TVL ratio sits at 30%. With Bitcoin, it's at 0.1 to 0.3%, right? So there's a massive growth potential right there just sitting in front of us. And so far, this has been hindered by the fact that there's been a massive chasm between adoption and innovation, right? People get into Bitcoin, 99% arguably, or maybe 90% of the crypto users start with Bitcoin. And then you go out and you try out DeFi and you try out all of these cool things that are happening in the networks, including ZK, right? I mean, a lot of the ZK research has been made production ready on Ethereum. So Bitcoin Layer 2s are the solution. Ultimately, what we want to achieve is create a full ZK rollup on Bitcoin, right? ZK is the future. That's the way to go. We want to be sure that execution is correct and prove that efficiently. But there's a few challenges. First of all, Bitcoin security and bridges for Bitcoin Layer 2s is a novelty, right? So far, up until recently, there was not even a way for us to figure out how to properly inherit Bitcoin security, how to build a rollup, and build a trust-minimized bridge. After the Taproot upgrades, we discovered BitVM. Robin Linus came up with the idea of, okay, we can't really hack a ZKP verifier directly into Bitcoin script to execute it in a block, but we can do this optimistically using the same optimistic fraud-proof techniques that are being used on Ethereum. And that is now actually possible with BitVM 2. That is the most kind of production-ready. I mean, production-ready is probably an overstatement, but we have a blueprint of how to build this. And we, for example, with Bob, we just announced our BitVM testnet recently. But there's other things we have to achieve, right? It's not just about the tech. And I know we're at a ZK event, and I'm talking about, well, tech is not everything, but we have to realize that building an ecosystem is just as important, right? Building the tech and hoping that people will come is not enough. We have to make sure that builders can deploy their products and have a go-to-market strategy that doesn't involve them rebuilding everything from scratch. And last but not least, liquidity. We can build a secure bridge. We can take the EVM, fork it, and deploy that on a separate chain. But if there's no way to get access to stable coins, no way to get access to other assets, what are you going to do there? Nothing. And that's why Bob is building a hybrid layer 2. So our goal is to inherit Bitcoin security, access Bitcoin liquidity through a trust-minimized bridge that's powered by BitVM, and that's where the whole ZK component comes in, just to link it back to the event today. But at the same time, we're in EVM, powered by a P-stack. We have the best-in-class DeFi infra. There is no difference between building on Base, Optimism, or on Bob today, which is super important for app builders and app developers. And last but not least, and that's where the hybrid aspect comes into play, we're using the Ethereum network as a connected network to inherit DeFi network effects. And the way this works, and now we're diving into the tech. So what we do is we use Bitcoin as a trust anchor. So what we want to make sure is that you use Bitcoin as security, because ultimately, no matter whether you're ETH maxi, a Bitcoin maxi, Solana maxi, we can all agree on that Bitcoin is secure. The second item of the agenda is using BitVM to create a trust-minimized BTC bridge. And again, fraud proofs, not ZK rollups, not full ZK validity proofs. But I'll talk about BitVM in a second, and you'll see where exactly the ZK component is in that construction. And then last but not least, we create a native ETH bridge that verifies finality on Bitcoin instead of waiting for Ethereum fraud proofs. So if it pieces all together, right, you have Bob here Bob will inherit Bitcoin finality. I'll talk about this in a second. And on top of that, we build the BitVM bridge that allows us to deposit and withdraw trust in a trust minimized way. Now, this thing basically verifies that Bob has finalized on Bitcoin. And then on the Ethereum side, we modify the bridge contract to not wait for Ethereum fraud proofs, right? Because if you're building or like validate Ethereum ZK proofs, because if you're an ETH rollup, what happens is you basically verify what's going on here. So if you're depositing into Arbitrum, Optimism, or a ZK rollup, what you'll do when you want to withdraw, you'll wait until that thing is finalized on Ethereum. Now, what we do instead is we add this Bitcoin Light Client component. The Bitcoin Light Client allows us to verify specific transactions and the Bitcoin state. So we know that a certain Bitcoin block is indeed a part of the main chain, has proof of work over it, and I can check that certain transactions have happened on Bitcoin cryptographically. This is the same thing that you have on your mobile phone, but implemented as a smart contract. Now, why do we do this? Instead of verifying that Bob has finalized on Ethereum, this thing looks at Bitcoin and says, oh, in block 1 million, the Bob block 10,000 has actually been finalized. And that's how we know that we can securely withdraw the funds. That's how we know that the state is actually correct. And this allows us to create this hybrid design where for the ETH user, it looks and feels like an ETH rollup, but actually secured by Bitcoin. And the only thing you trust in addition to Ethereum is Bitcoin, which, again, arguably, we're all fine to do. And the cool thing with this hybrid design, and that's our vision, is we can connect this to many other chains. Any network that has smart contracts can verify Bitcoin, right? On Ethereum, this has been possible since 2016. Now, the majority of these chains already have Bitcoin Light clients deployed. So the only thing they need to do is just point that Light client to look at Bitcoin and know for which transactions to verify. And that's how Ethereum, OP, Scroll, Binance Chain, Polkadot, Cosmos, whatever you like, can create trust minimized bridges to Bob, deposit assets, trade them against Bitcoin and other assets, and always withdraw to the underlying layer 1, as long as you can check that Bob has finalized on Bitcoin. So that's the vision, and that allows us to, replace centralized exchanges, because instead of trusting a centralized provider, you're trusting Bitcoin finality. And vice versa, we can export BTC to these networks in a secure manner, because again, these connections are secured by Bitcoin itself. So of course, if you're bridging Bitcoin into Bob and then using BitVM, so you get this trust minimized design, and then you want to bridge it out to Ethereum, naturally you trust that Ethereum works. Of course, otherwise you wouldn't be using that. But that connection from Bob to Ethereum does not require anybody else, right? That's secured by Bitcoin. You don't need a third-party bridge, which minimizes trust and reduces risk. So how does this actually work? How do we go from ETH2, which what Bob is today, to actually this hybrid design? And then I'll walk you guys through this BitVM and Bitcoin staking mechanism we're employing. So right now, Bob is an ETH2. That's pretty straightforward, right? We have a sequencer, produces transactions, collects them, produces blocks, and posts data to Ethereum, and then we should be able to have fraud proofs. Now, interestingly, it turns out fraud proofs are much more difficult to do on Optimism and Ethereum than ZK proofs. So what we're doing right now is we're preparing an upgrade to have ZK proofs here, and then Bob will be a stage 2 rollup. So that's pretty straightforward because, this tech has been commoditized. You can use succinct risk zero. There's so many other providers that offer this out of the box, specifically for the OP stack. So if you're thinking to build a layer 2 on Ethereum or something like that, definitely check out OP stack. We're part of the super chain, so naturally we're biased, but this thing really works. And so far we've been focused on, on the product side, making it super easy to deploy Bitcoin into DeFi and other applications. I'll talk about this a bit later. But let's first talk about the technological aspects. So what we're rolling out right now on testnet and we'll be deploying to mainnet over the next couple of months is adding Bitcoin finality to the ETH rollup. How do we do this? So what we do is we have the sequencer that produces blocks, collects transactions, produces blocks, and then once we upgrade to being a stage 2 ZK rollup or validity rollup, we'll be posting proofs to Ethereum. But we don't stop there. We're not just an ETH-connected chain. So before we post those proofs to Ethereum, we send them to the Bitcoin stakers. And here we work with Babylon, where stakers lock up their BTC on Bitcoin L1, and then the technique that Babylon uses is an improved version of stake chains, a protocol that was also actually invented by Robin Linus, the inventor of BitVM, but back in 2021. And the idea is actually quite interesting. It makes use of a vulnerability in how ECDC or Schnorr is actually implemented on Bitcoin. And the specific attack here is the nonce reuse attack. The idea is as follows. Whenever you sign a block on Bob, you know what the block number is. Now, the idea is that if you sign two messages that have the same nonce, which is a number that you set whenever you're signing a message, your private key will actually be leaked on Bitcoin. So if that's why your wallets are designed in a way that you always change the nonce. If you'd sign the same message or like a message and you reuse the nonce, your private key will be leaked and your Bitcoin are gone. And it's exactly what Babylon uses here with, of course, some improvements. But the idea is if the Babylon stakers sign off on one version of the Bob chain, and then they sign a conflicting one, a fork, and that gets published, their private keys on Bitcoin will be revealed and the Bitcoin stake is gone. And that's how slashing works in this system. It's very simple. It's actually an attack that is being used as a product, which is pretty cool. You should definitely check it out online. I don't have the links here, but it's actually a very simple system. No. So what do? We send this to the Babylon stakers. They verify the ZK proof, which is pretty straightforward, and then they sign off. And then they post commitments to Bitcoin regularly. And after a certain amount of blocks, we know that for certain Bob has finalized on Bitcoin. The Bitcoin stakers have signed off. And that's what we add to our submission to Ethereum. So now on Ethereum, you look at, okay, there's a ZK proof, the state has been valid, plus you get a sign off from the Bitcoin stakers that this is indeed the canonical chain. Why do we need this? First of all, it adds additional security guarantees because you have an additional group of signers that have billions of dollars staked that confirm that, well, yeah, you're not receiving a fork. Because, again, a ZK proof for a fork could also be valid, but have some double spend transactions in it. Now, we specifically need this for the BitVM bridge. And our BitVM bridge verifies that the Babylon stakers have signed off on the Bob state. Now, why do we do this? The BitVM bridge is a light client bridge design. That means we're verifying a light client for Bob, or specifically, we want to know, has there been a transaction when we're withdrawing Bitcoin from Bob to Bitcoin L1? Has there been a transaction on Bob that burns wrap BTC, and that recipient should be the one claiming the Bitcoin on the Bitcoin layer 1? We need to know, that actually has happened, and that transaction is part of the Bob main chain and has been finalized. And the interesting part is that Ethereum does not have a secure light client. I cannot easily implement this for Ethereum. Ethereum's light client is vulnerable, and it burns down to multisig at the end of the day. Why? Because the sync committee can't sign off on invalid states as long as they sign off on honest states, and they won't get slashed. That's a problem with Ethereum itself. Nothing we can do there. But also a lot of these other chains, right, do not have secure light clients. So that makes building bridges to these things in a trustless manner very, very hard. So instead, we have to revert to Bitcoin. And we say, okay, the Babylon stakers confirm that the Bob state is valid, that the withdrawal transaction has indeed been included, that is committed to Bitcoin, and that's exactly what we verify in BitVM. So that's why we post this to Ethereum and hence ensure that everybody is on the same page, and then we have Bitcoin security network, and we can create a trust minimized Bitcoin bridge. And then in phase 3, eventually we can move the proofs from Ethereum to Bitcoin. I'm not going to talk about this right now because it's not feasible today. Fraud proofs require you to post data continuously. Right now, that will be too expensive, and hence it's more on the research side of the roadmap, not something we're implementing this year. So I think this is the wrong version of the deck, actually. Let me see. Yep. That's unfortunate. Okay, so I was going to explain how BitVM works. I'll have to do it without a visual support, so you guys have to use your fantasy and imagination. So BitVM, actually, if you guys have the magazine that was printed by House of ZK, there's actually a very nice image on the Bob side that actually explains how BitVM works. So if you have that next to you, take a look. I don't know which page it is on. So how does BitVM work, right? Where is the ZK component in BitVM? So if we take a step back, what are we trying to do? We're trying to hack a ZKP verifier into Bitcoin. Ultimately, that's what we want to do. Now, what many people don't know is that in Bitcoin, using Bitcoin script, we can write arbitrary programs, right? People always say, oh, Bitcoin doesn't have smart contracts, it doesn't have Turing-complete languages, you can't really do anything. That's actually not true. Bitcoin script can be used to build anything, but it's super inefficient. Like, it's a low-level programming language where you have to write everything yourself, even multiplication, right? So think about it this way. If you're multiplying two numbers in Solidity, I mean, you don't really think about it, right? Variable A times variable B, you call the multiply function, done. Well, in Bitcoin, you have to write your own multiplication function every single time. So you use logical gates and whatnot. Oversimplified, right? If we were to kind of zoom out from the technical aspect, think of like, okay, in Solidity, you write A times B, like 2 times 10. In Bitcoin script, you'd be adding one after the other, which is super inefficient. As a result, something that's like 5 lines of code in Solidity can be 1,000 lines of code in Bitcoin script. So that leads to the following problem. Yes, we can implement a snark verifier in Bitcoin script, but it's going to be a gigabyte in size, and that's already super optimized. We cannot fit that into a transaction, just doesn't, not even into a single block. And from there, we have two choices. I'm sure you've all heard about the OP-cat and like the Covenant debate, which opcodes do we add to Bitcoin. That path tries to introduce additional functionality, so we basically can reduce the lines of code. Again, I'm oversimplifying this, but the goal is add functionality that we can use to just compress these programs so we could fit them into a 4 megabyte block and hence fully verify the proof on chain. Now, in absence of these forks comes BitVM. BitVM says, all right, we can't do this on-chain for every proof, so let's do this optimistically. We know we can execute a program that of up to 4 megabytes in size. So let's take the 1 gigabyte and chunk it up into 4 megabyte pieces. If you execute each of these 4 megabyte pieces sequentially, you'll get the same result as of the original program. So using multiplication as an example, imagine it this way. You want to multiply two numbers, so what you do is you split it up into the additions, right? So if you're trying to multiply 2 times 10, what you're going to do is you're going to start with 0, and then you're going to do plus 2, plus 2, plus 2, plus 2, plus 2, until you have the right number. Again, oversimplified, it's much more complex in practice with a ZK verifier. So, okay, now we've split up the program. What do we do now? As an operator, I will commit on-chain using taproot trees and pre-signed transactions, and that's where the visual would have been helpful, but we'll skip. Just imagine we're committing to executing a specific set of programs. And that commitment happens on-chain, so now everybody knows that if I execute a different program and you hash it and whatnot, you can reconstruct it, you'll see that there's a difference. Well, then I run the program, right? So let's say you've commissioned me to add two numbers, which is obviously a very stupid example because you can do that at home, but let's say we do that. You've deposited some money into that program, and if I give you the right result, I can get the money. So I then announce, oh, 2 times 10 is 19, which is obviously wrong. You can verify this on your local computer. On your local computer, you'll see, wait a second, that's wrong. But to prove that I was wrong, you need to know where exactly I modified the program, because that's how you can enforce and show to all the Bitcoin full nodes that Alexei is cheating. So what do? You challenge me. You post a transaction on-chain that says, wait a second, I'm challenging Alexei, that's nonsense. And then I have, let's say, 7 days or a few hours to respond. If I don't respond, I'm out. If I do respond, I have to post all my intermediary results of that program. So I start with 0, and then I post 2, 4, 6, 7, 9, and so on. And you can see, well, that's exactly where I went wrong, because in your program execution trace, you know that it shouldn't be 7, it should be 8, because obviously 6 plus 2 is not 7. So what do? You go on chain, you take that chunk, that piece of the program, and you execute it, given the inputs that I've given in the previous state. And the way we're committing to these programs in the BitVM construction allows you to open a commitment. We use Lamport or Winternet signatures, and that allows us to prove that Alexei's, my commitment for that subprogram, is not what I actually executed. You can prove that it should have been 8 and not 7. And that's what is executed by all the Bitcoin full nodes. And so everybody in the Bitcoin network knows that I cheated, and hence my transaction, the attempt to withdraw money from the deposit to claim the money for obviously this wrong computation, will be rejected and invalidated. And that's how BitVM works. So in short, take a big program, chunk it up, commit to it, and if you get challenged, post intermediary results so that the challenger knows exactly what to disprove. If I don't respond, I lost anyway, I'm out, because obviously I cheated. So where does a ZK come into play in BitVM? Well, the ZK comes into play in the pre-processing step. We could take any program, and I know the BitVM name is a bit confusing because it has the VM name in it, but it actually has nothing to do with virtual machines. You can take arbitrary computation. Now, in the latest design in BitVM 2, what we do is we say, look, let's take any program that we can generate a snark proof for and a corresponding verifier. So we actually prove the correct execution of a bridge, of a full chain of Bitcoin, whatever. And then we take that verifier that is constant in size, and that's the input to BitVM. So that's the program that we then chunk up and so on. So what are we verifying? We're optimistically verifying that I, as an operator, was able to correctly executed the program that you want me to do and proved it in a ZK proof. And that's what often leads to confusion with the whole ZK rollup narrative around Bitcoin. ZK is part of BitVM. It's a pre-processing step, but it's not a ZK validity rollup as we know it from Ethereum. And that is quite important to understand because, of course, the trust assumptions are different. With introduction of things like OPCAT, we will be able to compress the size of the program. We don't have to chunk it. We can execute it fully on chain. But even then, it's going to be very expensive. So in practice, most likely, we will always see fraud-proof based designs in the foreseeable future. Right. Now, I have a bunch of other slides that actually don't have anything to do with this. So I'm just going to skip over that and just say that Bob, on our side, we recently completed the BitVM test and implementation with Fiamma. Yuval is actually there in the back. So if you want to ask questions about some of the implementation details, they're one of the strongest BitVM teams in the space. You can try this out. Scanning this QR code, you won't see much of BitVM though, right? Because it's hidden. One of the problems of BitVM is that it's actually quite complex to execute, right? You as a user, you don't want to run a special program. You don't want to deal with setups and signatures. You just want to bridge your Bitcoin in. And so what we do, and actually that's where the slides become relevant, is we build a one-click program or one-click kind of interface that allows you to deploy your Bitcoin from various wallets, custodians, whatever ledger, whatever you like, into a bunch of DeFi protocols. And the way this works is swaps. So instead of going to your preferred bridge provider, KYCing with WBTC, or running a special program for BitVM, you let professional operators do that. They run the service, and you're just swapping. You're trading Bitcoin against the final position. So the idea is, instead of doing this, so native Bitcoin, wrap it, and then you stake it into Babylon, and then you put it into a DeFi protocol, you just swap into the position directly. And we can do trustless swaps using, again, cross-chain proofs. So I lock up my Bitcoin as I lock up whatever position you want as the operator. You send Bitcoin to me and automatically can claim this because the smart contract can verify that you've made the payment. And that's how we make BitVM user experiences actually nice, because ultimately, and if you go on this, if you go here, you probably expect some fancy command line shit and operators and whatever. But it's actually very simple. It looks and feels like any other bridge, and that's the whole point. Retail users will not see the complexity because otherwise nobody's going to use this. We'll be releasing operator software and ways to onboard as an operator over the next couple of weeks, and that's where you can then start playing and trying actually to attack the system. So we're going to run bounties where you can try to, on testnet, deploy some Bitcoin, and if you can steal it, you might get a prize to actually battle test the system. And then last but not least, I'm also super excited to announce that we've created something called the BitVM Acceleration Working Group. It's an open-to-all working group where we bring together BitVM research teams with institutional partners. Why do we do this? I went to a conference last year, also in Denver, and there's one Bitcoin focus in Dubai, was telling everybody about BitVM, and it was super new. We've made so much progress since then, where we have test nets, we have actually proper systems, there's audits going on. And then we realized, when I was there this year again, and same in Denver, well, nobody knows, right? None of the operators, none of the custodians, none of the companies that will be affected by this actually have visibility. And we're building things that they might not even be able to run because it's not profitable, it doesn't fit with the infrastructure, whatever. And that's why with the BitVM Acceleration Working Group, we bring institutional custodians, market makers, staking providers, funds, and soon wallets and DeFi providers to make sure that we're building exactly the right product that allows them to take the existing centralized rapid AC providers and upgrade them to trust minimized BitVM bridges. If you're a staking provider, a validator, a custodian, a wallet operator, or even a DeFi protocol, and you want to get involved, check out bitvm-org, submit an application. This is free for all. We'll be onboarding more partners, and we'll be hosting the next meetup at Bitcoin Vegas. We'll be hosting workshops and making sure that everybody understands what BitVM is and what are the roles and how actually you can get involved. And with that, thank you so much. Let's make Bitcoin the center of DeFi.
Thank you so much, Alexei.